Okay, the first problem is find the sum to infinity of a series. So 1 plus 3 by 2 factorial plus 5 by 3 factorial plus 7 by 4 factorial and so on. So in the exponential series, the denominator is always okay in the form of factorial. If it is not in the factorial, you should convert into factorial, and then you need to solve the problem. Okay. And also Purnachandra told that the binomial series, the numerator and the denominator form an AP in binomial series. Okay. So let us take S is equal to the given series. It is 1 by 1 factorial plus 3 by 2 factorial plus 5 by 3 factorial plus 7 by 4 factorial plus and so on. Okay, what is the first nth term here? Nth term. So in the first you should tell in the numerator, and then you can tell in the denominator. Okay, or if you know that if you know the nth term, you can tell. What is in the denominator? The denominator is a little bit easier.
N factorial, sir.
Yeah, n factorial is correct. Is it Uddhavan?
Yes, sir.
Okay. Okay. What about numerator?
N plus 2n minus 1, sir.
Yes, correct. 2n minus 1. Very good. So actually, the series is 1, 3, 5, 7, and so on. Okay, well, I think in the 10th standard, yeah, I think 10th standard is the formula படிச்சிருப்பீங்க nth term. Okay, well, a plus n minus 1 into d. If you know the first term and the common difference, then you can find the nth term. First term is what? 1 plus n minus 1 into d. Common difference is 2. So 1 plus 2n minus 2. Okay, wow. So 2n minus 1. So you know the formula, but you don't know where we need to use this formula. So that is the problem. Okay. So that, okay, 2n minus 1, that is in the numerator. So denominator you can easily find. Okay, first term 1 factorial, second term 2 factorial. So nth term n factorial automatically. So this s, how to get s from Tm? Okay, so if you take summation n equal to 1 to infinity, okay, okay. So this is a T1 plus T2 plus T3 plus T4 and so on. Okay, if you sum, you will get this S. So this is equal to summation n equal to 1 to infinity. What is the Tn? 2n minus 1 by n factorial. Okay. So now you should write the numerator in terms of denominator. Okay, in terms of denominator. So that is the idea. Then only you can cancel. So but here, so I will split the function n equal to 1 to infinity. Okay, 2n by n factorial minus 1 by n factorial. Okay, so anyway, here the numerator is in terms of denominator, because here n factorial, here I have n. Okay, so n factorial means you know that what is n factorial? N factorial equal to 1 into 2 into 3 into 4 into up to n. Okay, n minus 1 into n. So this is you can take 2 is also common on the first summation, 2 into summation n equal to 1 to infinity. Okay, so 2n by n factorial. Okay. So summation n equal to 1 to infinity n factorial, sorry, n by n factorial, n by n factorial minus, I think here I missed what? The second term I missed what? Summation, I missed the summation. Summation n equal to 1 to infinity 1 by n factorial. Okay. So minus the summation n equal to 1 to infinity 1 by n factorial. So this is equal to twice. Okay, what? Twice. So what is this? Summation n equal to 1 to infinity 1 by n minus 1. 1 by n minus 1 factorial. If I cancel n and n, remain you have what? N minus 1 factorial minus n equal to 1 to infinity 1 by n factorial. Okay. So now, okay. Actually, what is Tn here? Tn is what? Okay, I took the summation here. Okay. So can I write a Tn equal to like this? Tn equal to 2 by n minus 1 factorial minus 1 by n factorial. Okay, so actually I took only this portion. Okay, what? 2 by n minus 1 factorial minus 1 by n minus 1 factorial. So that is Tn. So I omit the summation. Okay. Suppose if you substitute n equal to 1, n equal to 1, what happened? T1 equal to what? 2 by 0 factorial minus 1 by 1 factorial T2. 2 by 2 minus 1 factorial minus 1 by 2 factorial T3. 2 by 2 factorial minus 1 by 3 factorial. Okay, I'll write one more term, T4, 2 by 3 factorial minus 1 by 4 factorial, and so on, T5. Okay, so now S is equal to t1 plus t2 plus t3 plus t4. So that is equal to, so here if you add vertically, okay, so so here is common, 0 factorial is 1, so 2 into 1 plus 1 by 1 factorial, 1 by 2 factorial plus 1 by 3 factorial and so on. And then if you add vertically, okay, 1 by 1 factorial, 1 by 2 factorial, 1 by 3 factorial, 1 by 4 factorial, take minus commonly. So what is this? So 1 plus 1 by 1 factorial plus 1 by 2 factorial, 1 by 3 factorial is what?
E power 1.
E power 1. Victory, yeah.
Yes, sir.
Okay. So what is this? E minus 1, because 1 is missing here. Okay. Okay, so 2e minus e is e, minus of minus plus 1. So S e plus 1 is the final answer. Second problem, sum to infinity of a series. Five by 1 factorial plus 7 by 3 factorial plus 9 by 5 factorial and so on. Solution. So let us take S is equal to the given series 5 by 1 factorial.
Sir,
Yeah.
can you show the question for a minute, sir?
Yeah.
Thank you, sir.
The second C pattern is 10 into 2, okay, 20 marks, and 10 into, sorry, 3 into 10, okay, 30 marks. So I think the first C also is the same pattern. I think there is no change in the pattern. Okay, sum to infinity of a series of 5 by 1 factorial plus 7 by 3 factorial plus 9 by 5 factorial and so on. So this is the given series 5 by 1 factorial plus 7 by 3 factorial plus 9 by 5 factorial plus and so on. So next we should find the nth term. So what is the nth term here? The numerator.
2n plus 3 by
Sorry, Purachandra?
2n plus 3, sir.
Yeah, 2n plus 3. Yes, correct. What about the denominator?
2n minus 1 factorial.
Yeah, 2n minus 1 factorial. The same idea, okay, 5, 7, 9 and so on, the numerator. A is 5 plus n minus 1 into d is the common difference, 2. So 2n plus 5 minus 2, so plus 3. Similarly, you can check. The denominator is 1, 3, 5 and so on. So A is 1 plus n minus 1 into d is 2. So 2n minus 2 plus 1, 2n minus 1. But here have factorial, so 2n minus 1 factorial. So earlier I told to you, you should write the numerator in the form of, in terms of the denominator. Okay, so you can write 2n minus 1. Okay, and then add 1 and then plus 3. Okay, divided by 2n minus 1 factorial. So this is equal to 2n minus 1 divided by 2n minus 1 factorial. I'm splitting the function plus 4 divided by 2n minus 1 factorial. Okay, so now, so your Tn is equal to, okay, 2n minus 1 factorial, you can write what? How to write 2n minus 1 factorial is 1 into 2 into 3 into up to 2n minus 2 into 2n minus 1. So if you cancel 2n minus 1, the numerator, and 2n minus 1, the denominator, remaining 1 to 2n minus 2. So in the denominator, we have what? 2n minus 2 factorial. So Tn equal to 1 by 2n minus 2 factorial plus 4 divided by 2n minus 1 factorial. So this is your Tn. So now S is equal to summation n equal to 1 to infinity. Okay, summation n equal to 1 to infinity. Sometimes it will come from 0 to infinity. It is depending upon the problem. So you should be very careful. Okay. Here it is n equal to 1 to infinity. So 1 by 2n minus 1 factorial plus 4 by 2n minus 1 factorial. So this is equal to okay. So I think it is better to do by okay. So I think it is better to do by Tn. Tn equal to what? 1 by 2n minus 1 minus 2 factorial. 2n minus 2 factorial. Okay, I think I don't need first this one. Okay, so please write. Okay, so now I'm going to substitute n equal to 1. What is the T1? T1 is what? One by 0 factorial plus 4 divided by 1 factorial. T2, what is T2? 1 by 4 minus 2, 2 factorial plus 4 by, this is 4 minus 1, 3 factorial. T3, 6 minus 2, 4 factorial plus 4 divided by, so this is 6 minus 1, 5 factorial. T4, 1 by 8 minus 2, 6 factorial plus 4 divided by 8 minus 1, 7 factorial, and so on. Okay, so now T1 plus T2 plus T3, if you add everything, that is S is equal to T1 plus T2 plus T3 plus T4 and so on. If you add vertically, you'll have 1 plus 1 by 2 factorial, 1 plus 1 by 2 factorial plus 1 by 4 factorial plus 1 by 6 factorial and so on. Okay, and then here, if you add vertically, if you take 4 commonly, you have what? 1 by 1 factorial, 1 by 3 factorial, 1 by 5 factorial, and so on. So what is this? Anybody? What is this expression?
E plus e power minus 1 by 2.
Okay, correct, Paritosh. E plus e power minus 1 by 2 plus 4
Sir?
times, yeah.
Sir, we are writing it as 4 into 1 by 1 factorial plus 1 by 3 factorial now, sir.
Yeah, 4 is common.
Yes, sir. Instead of that, if we write it as 3 factorial and substituting those 1 by 3 and 1 by 5 in the first expression, you would get e power 1, sir. It would be easier.
No, you will not get it. Okay, but what you will do the remaining terms?
The number of terms are equal, sir, so there will be no remaining terms, sir.
No.
The remaining terms 3 into 1 by 1 plus 1 by 3 factorial, 1 by 5 factorial, sir. Then we can apply the formula of e minus e power minus 1, sir.
So please tell how you are telling.
1 plus 1 by 2 factorial
Okay.
plus 1 by 3 factorial.
1 by 3 factorial is here.
Yes, sir.
You are choosing
Yes,
from
sir.
here.
Yes, sir.
Ah,
Plus 1 by 4 factorial and 1 by 5 factorial, sir.
okay. Okay.
Plus
So
3
plus,
into 1 by 1 factorial, and another one you have to write outside the bracket, sir.
another.
This 1 by 1 factorial, no, sir. We didn't take it out as common, sir. So
Yeah,
we have to
actually,
write it outside.
totally you have 4 times 1 by 3 factorial. Here you put 1 by 3 factorial, remaining 3 times 1 by 3 factorial. I got
Yes,
it.
sir.
Okay.
Plus 1
So
by
next
5
to 4
factorial.
times 1 by 4 times 1 by 5 factorial.
No, sir. 3 times only, sir. We have written it in the last term, sir.
Okay, 3 times 1 by factorial. Remaining 1 by 5 factorial.
Yes, sir.
I need to write separately. Okay, va? So you
Yes,
are
sir. That
writing
only
in
we
terms
have.
of,
Yes, sir. That
yeah.
remaining 1 by 5 factorial only we have written in the previous expression, sir. So only 1 by 1 factorial would be one more, sir, because we didn't write it in the previous expression, sir. So we have to
Okay,
write it outside
okay.
the bracket as 1, sir.
3 into, okay, 3 into 1 by 6 factorial.
Yes, sir.
Okay, so this is what? What is this expression?
E power 1, sir.
E. Okay, what about this one? Can you write? If you give the expression
We can
in
take
terms
3 as common out and use the same expression, sir.
1 by 3 factorial, 1 by 5 factorial, 1 by 6 factorial. I don't have any formula for this expression.
The 6 factorial, 1 by 6 factorial one comes, sir, because it is in
Yeah,
the
1 by
previous
6 factor,
expression.
1 by 6, 1 by 3 factorial, 1 by 4 factorial.
Is already in the expression, sir.
Where? Here.
No,
Whether
sir.
it is here.
No, sir. In yes, sir. Yes, sir. S is equal to T1 plus T2. That term you have written, no, sir. 1
Okay.
plus
That,
1 by 2, sir. We are taking 1 by 3, 1 by 5, and 1 by 7 from the next expression to make it as e power 1, sir.
so whether what I wrote is correct or not, first you should tell here.
Yes, sir. Here it is correct, sir. In the next expression, 3 into 1 by 7, sir. Not 1 by 6, sir. 1 by
1 by
6, 1 by
7.
7 factorial. Yes, sir. Instead of 1 by 6, sir.
I don't get it. 1 by 7, okay. 1 by 1 factorial, 5 factorial. Okay, 1 by 7 factorial. Okay.
Yes, sir.
So, okay, 3 into 1 by 3 factorial, 1 by 5 factorial, 1 by 7 factorial. Okay. I think here, what is the formula here we have? 1 plus 1 by 3 factorial, 1 plus 1 by 5 1 by 5 factorial, 1 by 7 factorial. Is it correct? So
Yes, sir.
what is this one? What is this?
E minus e power minus 1 by 2.
E minus
E power minus 1 by 2.
e power minus 1 by 2. But here, first term is missing.
-1 also, sir.
Minus 1. Okay. So into 3 times. Because 3 is here. Okay. So here I have E. So I need to add here E. It's a rough work. Okay. E plus 3 times. If I take 2 is LCM. 2 is LCM.
Sir,
Yeah.
you left the 4 into 1 by 1 factorial, you left, sir. You started from 4 into 1 by 3 factorial, sir. You have taken 3 as common, sir. But you forgot to write first term, sir. 4 into 1 by 4 factorial.
Oh, okay. That is, yeah, 4 times 1 factorial.
That extra one will come outside as +1, sir. 3 into 1 plus 1 by 3 factorial and the whole term, sir. Outside the bracket +1, sir.
Okay. So to avoid these things, okay, Uddavan,
Yes, sir.
okay, so நமக்கு ஈஸியா ஒரு மெத்தட் இருக்கு. ஓகேவா?
Okay, sir.
ஓகேவா? So what you done it is correct, but it is not an effective method. The reason is it is not in the I think you need to group it. இதில் ஒரு கம்ஃபர்டபுளாக ஒரு உனக்கு ஆல்ரெடி இங்கே வந்து ஒரு சீரிஸ் எக்ஸ்பான்ஷன் இருக்கு. ஆல்ரெடி 1 plus 1 by 2 factorial plus 1 by 4 factorial plus 1 by 6 factorialக்கு you have the formula already. E plus e power minus 1 by 2. Similarly, 1 by 1 factorial plus 1 by 3 factorial plus 1 by 5 factorial plus 1 by 7 factorial, you have the formula what? E minus e power minus 1 by 2. Is it correct, Paritosh?
Yes, sir.
So, you take here 2 LCM. I take 2 LCM. What is the numerator? E plus e power minus 1, 4e minus 4e power minus 1. So in the numerator we have 5e minus 3 into e power minus 1 by 2. I finished the problem. Okay. So even if you try that method, you will get the same answer. You can verify and check it later.
Okay, sir. Thank you, sir.
Yeah. So third problem, sum to infinity of the series sum to infinity of the series. The third column, summation n equal to 1 to infinity 1 square plus 2 square and so on plus n square divided by n factorial. Okay, solution. So here what is the nth term? Tn.
n square by n factorial, sir.
No.
Sir, in the numerator, you want the formula of squares of numbers, sir.
Okay, Paritosh, you are right. But first you should tell the nth term and then you can go to the next step. I think you are going to the second step.
Okay, sir.
What is the nth term? I think it is visible to everyone.
N square by n factorial, sir.
Okay, the one. Okay, I will give the idea. The first
So
term.
only n square.
திருமகன் கரெக்டா யோசிச்சு பாரு n ஸ்கொயர் எப்படி வரும்
1 square plus 2 square till n square by n factorial.
Very good, Bhavan. Very good. So 1 square plus 2 square plus up to n square by n factorial is the nth term. So first term is what? Bhavan, n square by 1 factorial. Second term is what? 1 square plus 2 square by 2 factorial. Third term is 1 square plus 2 square plus 3 square by 3 factorial. So nth term is should be what? 1 square plus 2 square plus 3 square up to n square by n factorial. Okay. So those who gave the answers, wrong answers, okay, so don't worry. Okay, I think because of your answer only, I gave this explanation. Otherwise, I don't give the explanation. Okay, so sometimes the wrong answer leads a good discussion. So maybe the remaining students know. Okay, so how to find the nth term for this problem?
Sir, n into n plus 1.
Okay, first I will write it. Purachandra, first I will write the nth term as it is. Now the numerator is sum of squares of the
n natural numbers.
n natural numbers. Okay, please tell now.
n into n plus 1
n into n plus 1
into 2n plus 1 by 6.
Yeah, 2n plus 1 by 6. Okay, n factorial. Okay, this is actually Tn. Okay. So now, if you cancel 1n, you will get what? N plus 1 into 2n plus 1 by 6 into
n minus 1 factorial.
n minus 1 factorial. Okay, so the numerator is what? Quadratic. Okay, the numerator is 2n square plus n plus n plus n 3n. N plus 2n is 3n plus 1 into 1 1 divided by 6 into n minus 1 factorial. So I told that always I told that you should write the numerator, okay, numerator in terms of the denominator. In terms of the denominator. So leave this constant. Leave this constant. Consider the numerator is a quadratic. So 2n square plus 3n plus 1 is equal to a plus b into the denominator plus c into the denominator into denominator minus 1. So the left hand side also quadratic, right hand side also quadratic. So I want to split the given function like this in such a way that I need to find the constant a, b, c. In the previous problem, it is little bit easier. So that's why I don't do like this. Directly I will add and subtract in the numerator. I simplified. But here it is not possible. Okay, just add and subtract is not possible in the numerator. That's why I forced to like write like this. Okay, so now if you compare the compare you can compare coefficient of n square, compare the coefficient of n, but the other way you can put n equal to 1. If I substitute n equal to 1, this is what, 2 plus 3 plus 1 is equal to, this is 0, this is 0, you'll get a. So this implies a equal to 6. Now substitute n equal to 2. N equal to 2. So this is what? 4 into 2, 8. 8 plus 6, so 14. 14 plus 1, 15. 15 equal to a plus b. This is 0. We know that a is 6. This implies b is 9. Okay. Now substitute n equal to 0. What happened? That is the constant term. Okay, 1, left hand side is 1, right hand side is a plus minus b. Okay, n is 0 means this is 0, this is 0, plus 2 plus 2c. So we know that a is 1 equal to, a is 6, b is 9 plus 2c. So this implies this is minus 3 plus 4. 4 equal to 2c. So this implies c equal to 2. So we got the value of a, b, c. Okay. Now 2n square minus 3n plus 1. n square plus 3n plus 1 equal to a is what? 6. B is 6. B is 9 into n minus 1. Okay. C is 2 into n minus 1 into n minus 2. Okay. So now what is S? Okay, S is equal to summation n equal to 1 to infinity. S is equal to actually T1 plus T2. Okay, first I will write S is equal to T1 plus T2 plus T3 and so on. Okay. What is Tn? Tn, this is a Tn. Okay. Please write. So Tn equal to, the numerator is 2n square plus 3n plus 1. So instead of 2n square plus 3n plus 1, I will write 6 plus 9 into n minus 1 plus 2 into n minus 1 into n minus 2 divided by 6 into n minus 1 factorial. Okay. So if you split 6 by 6 into n minus 1 factorial, 6 gets cancelled. 1 by n minus 1 factorial plus 9 by 6 means 3 by 2. So if you cancel n minus 1 and n minus 1, remaining is what? 1 by n minus 2 factorial. 2 by 6, 1 by 3. If I cancel n minus 1 and n minus 2, remaining you have 1 by n minus 3 factorial. So actually this is a Tn. Okay. So n starting from 1 to infinity. If I substitute n equal to 1 to infinity, T1. T1 is 1 by 0 factorial is 1. Okay, plus 3 by 2. So this is a negative. So it will not, okay, so this is not defined. So that's why I leave it. Just you have the first term only, 1 by 0 factorial. T2. T2 is what? 1 by 1 factorial plus 3 by 2 into 1 by 0 factorial. Here 2 minus is a negative number, so that's why I don't write here. And then T3, 1 by 3 minus 1 is 2 factorial plus 3 by 2, 3 minus 2 is 1 factorial plus 1 by 3, here 1 by 0 factorial. And then T4. T4 equal to, what is T4? Please tell. 1 by 3 factorial plus 3 by 2 plus 3 by 2 into 1 by 2 factorial plus 1 by 3, 1 by 1 factorial. So write one more term, 1 by 4 factorial, please check it, 3 by 2, 1 by 3 factorial plus 1 by 3, 1 by 2 factorial. So and so on. So now S is equal to, and so on, S is equal to T1 plus T2 plus T3 plus T4 plus T5 plus and so on. So here also I am going to add vertically 1 plus 1 by 2 1 by 1 factorial plus 1 by 2 factorial, 1 by 3 factorial, 1 by 4 factorial. So please write, the charger is too low. Put the charger. Okay. Okay, so I added first vertically, and then if I add vertically this one, if you take 3 by 2 commonly, so plus 3 by 2, 1, you have what? 1 by 0 factorial, that is 1 plus 1 by 1 factorial, 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial. And the last column, here 1 by 3 is common, 1 by 3 into 1, 1 by 3 into 1, plus 1 plus 1 by 1 factorial plus 1 by 2 factorial and so on. Okay, so this is what? 1 plus 1 by 1 factorial is E. S is equal to E plus 3 by 2 times E plus plus how many times E? 1 by 3 times. Okay, so please check it. So if you take 6 is LCM, 6E plus 3 3 into 3 9E plus 2E 15 17 E by 6. Okay, got it, Thirumohan? Can we go to next column?
Yes, sir.
Okay. The fourth problem, find sum to infinity of the series.
Sir, one show the previous slide, sir.
Okay.
Second. Previous second one, sir.
Previous, what
Yes, sir. Okay, sir. Okay, sir.
got it? You wrote
Yes,
it?
sir.
Yeah, okay. Fine. Find the infinity of the series summation n equal to 0 to infinity phi n plus 1 by 2n plus 1 factorial. Okay. So now here the nth term is Tn. Okay, wow. So nth term is what? Uddavan.
Sir, same sir. 5n plus 1 by 2n plus 1 factorial.
Yes.
Sir.
Okay, correct, Uddavan. Phi n plus 1 divided by 2n plus 1 factorial. Okay. So we need to write the numerator in terms of the denominator. Okay, in the last column, the numerator is quadratic. So that's the reason you wrote the numerator 2n square plus 3n plus 1 equal to a plus b into denominator plus c into denominator minus 1. But here the numerator is linear. Okay, so phi n plus 1 is equal to a into the denominator a plus b into the denominator. That is enough. Denominator without the factorial. Okay, so now we should find the value of a and b.
Sir,
Yeah.
sir, we can write numerator as 2n plus 3n plus 1 also.
2n plus 1 and then plus 3n.
Plus 3n.
Okay. Okay. But here again the problem is n. I need to write this here. This is also in terms of 2n plus 1. Okay.
Okay, sir.
I can't cancel. You can cancel. Okay, but if you cancel n, then something, it's a discontinuous series. So using that one, it is very difficult to find the summation. I think Purnachandra got.
Adding 3 by 2 and
Sorry,
adding and subtracting 3 by 2.
adding and subtracting
3 by 2.
3 by 2. எங்க பவன் எந்த இடத்துல கரெக்டா சொல்லு.
Numerator.
இங்கயா?
Ah.
5n plus 1 Add and subtract 3 by 2. Okay. If I, okay. So I think you are correct. What happened? Okay, minus 3 by 2. If we keep it this one, this is 5 by 2. Okay, 5 by 2. So 5n plus 5n plus 5 by 2. 5n plus 5 by 2. கிளாஸ்ல கிளாஸ் முடியல. Okay. Yes, 5 by 2 minus 3 by 2. So if you take 2n plus 1, I need 2n plus 1. So if you take 5 commonly, n plus 1 by
5 by 2 common, please.
5 by 2 commonly. Okay, so 2n plus 1. So you are correct, Bhavan. So your idea is correct, but only few students will write these types of okay. The reason is this is not a general method. I think you understand what I am telling now.
Yes.
So okay, so if I tell one general method, then if using that method, if you can solve all the problems, then it is useful for the majority of the students. Okay, so what your suggestion is correct. Okay, you can follow the suggestion, you can get the answer, but I am not going to use that one. Okay. Yes. The reason is, if you write the numerator like this, numerator is linear, so a plus b into denominator. Okay. Suppose if you compare the constant term, compare constant term, that is 1 equal to a plus b. Okay. And then if you compare the coefficient of n, what is the coefficient of n left hand side? 5. Right hand side, what is the coefficient of n?
2b.
2b. Yes. So this implies b equal to 5 by 2. If I substitute here b equal to 5 by 2, 1 equal to a plus 5 by 2. So a equal to 1 minus 5 by 2, a equal to minus 3 by 2. And b equal to 5 by 2. So now substitute these values here. So 5n plus 1 equal to a is minus 3 by 2, b is 5 by 2 into 2n plus 1. 2n plus 1. Okay. So now what is the Tn? Tn equal to, I will write Tn, nth term. Nth term is what? 5n plus 1 divided by 2n plus 1 factorial. But we know that pi n plus 1 equal to 3 by 2 plus 5 by 2 into 2n plus 1 whole divided by 2n plus 1 factorial. So this is Tn. Now split the function.
Minus 3 by 2, sir.
Minus 3 by 2. Thank you, Paritosh. Minus 3 by 2. So if we split the function minus 3 by 2 into 1 by 2n plus 1 factorial plus 5 by 2 into, if you cancel 2n plus 1, 2n plus 1, you'll get 1 by 2n factorial. Okay. So I need to start from where? T1.
T0, sir.
Yeah, that's why I'm asking. Yeah. Because here what? You start from 0. Okay. So you start from n equal to 0. So minus 3 by 2. Thank you, the one. Minus 3 by 2. 1 by 1 factorial plus 5 by 2. 1 by, this is 0 factorial. T1 minus 3 by 2 into 1 by 2 plus 1, 3 factorial plus 5 by 2 into 1 by 2 factorial. Okay, and then substitute t n equal to 2. So please tell the expression. Minus 3 by 2 is common. 1 by 5 factorial.
5 factorial
1 by 5 factorial
plus
plus 5 by 2
into 1 by 4 factorial.
5 by 2 into 1 by 4 factorial. We will write one more term. T3 equal to minus 3 by 2 into 1 by 7
7 factorial
plus 5 by 2 into 1 by 6 factorial. Okay, thank you, Paritosh. Now S is equal to T0 plus T1 plus T2 plus T3 and so on. Add vertically. If you add, you'll get common is what? Minus 3 by 2. 1 by 1 factorial, 1 by 3 factorial, 1 by 5 factorial, and so on. Okay, if you add vertically, the second one, 5 by 2 is common. 1 by 0 factorial is 1 plus 1 by 2 factorial, 1 by 4 factorial, 1 by 6 factorial, and so on. What is the first series?
e minus e power minus 1 by 2.
Correct. E minus e power minus 1 by 2. So this is e plus e power minus 1 by 2. Okay, correct, Paritosh. This is equal to minus 3 by 2. E minus e power minus 1 by 2 plus 5 by 2 into e plus e power minus 1 by 2. Okay. So here I took commonly 1 by 4. So minus 3e plus 3 e power minus 1. So I took 1 by 4 commonly. Remaining is what? 5e plus 5 into e power minus 1. So this is equal to 1 by 4. Okay, if you add e terms, you have 2e, e power minus 1 term, 8 e power minus 1. If you divide by 4, we have e by 2, plus 8 by 4 is 2 e power minus 1. E power minus 1 you can write e. So 2 by e, e by 2 plus 2 by e. So this is the final answer. The fifth problem. Find the sum to infinity of the series one by 1 factorial plus 1 plus 5 by 2 factorial plus 1 plus 5 square by 3 factorial plus and so on. So this is the first term, this is the second term, this is the third term. So I need the nth term. So what is the nth term? 1 plus 5 plus 5 square plus up to what? 5 power
N.
Uddhavan, sorry, Purnachandra, is it correct?
N minus 1, sir.
Yeah, n minus 1. N minus 1. Rahula.
Yes, sir.
Okay, n minus 1. Divided by n factorial. Okay. Now, but if you add the numerator, what you will get? 1 plus 5 square plus 5 power n minus 1. Please tell. If r is greater than 1, then what? Paritosh?
If r is greater than 1, then a into r minus 1 up to some power n. Yes, sir, upon r minus 1.
Very good. So, okay. So, if this is if r is
r greater than 1.
If r is less than 1, then a into 1 minus
1
r
minus r power n
by
1 minus
1
r.
minus r. Okay. But here r is greater than 1. So, this is equal to the numerator equal to what? Numerator equal to a. A is what? First term is 1. So, 1 into 5 power n minus 1 divided by 5 minus 1. Okay. 5 minus 1 into 1 by n factorial. Okay. So this is equal to, the numerator is what? 5 power n minus 1 divided by 4 into n factorial. Okay.
Excuse me, sir.
Yeah, please tell.
Sir, what is the value of A, sir?
A is first term. A is 1.
Oh, okay, sir. Okay, sir.
So now I am going to split the function. Okay. If I split the function, you will get what? Well, take 1 by 4 is also common. Okay, 1 by 4. 5 power n by n factorial minus 1 by 4 1 by n factorial. 1 by n factorial. So this is a Tn. Okay, n varies from where to where? I think n starting from 1. Okay, n is starting from 1. So T1, what is T1? 1 by 4, 5 power 1 by 1 factorial minus 1 by 4, 1 by 1 factorial. T2, 1 by 4, 5 square by 2 factorial minus 1 by 4 into 1 by 2 factorial. T3, 1 by 4, 5 cube divided by 3 factorial minus 1 by 4 into 3 factorial. Okay, and so on. So now S is equal to T1 plus T2 plus T3 and so on. So if you add vertically, 1 by 4 is common. Okay, 5 by 1 factorial plus 5 square by 2 factorial plus 5 cube by 3 factorial plus and so on. If I add vertically this one minus 1 by 4, you can take commonly 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial and so on. Okay. So what is the first expression? What is the second expression?
First one is e power 5.
Paritosh, is it correct? First term is missing.
No, sir, e power 5 minus 1.
Yes, now it is correct. Yes. 1 by 4 into e power 5 minus 1. Similarly, the second term, here also 1 is missing. Yeah. So minus 1 by 4 e power 1 minus 1 or e minus 1. So take 1 by 4 commonly. Remaining is what? E power 5 minus 1 minus e plus 1. So the final answer is 1 by 4 plus 1 minus 1 gets cancelled. Okay, e power 5 minus e, or you can take e is also common. Okay, e power 4 minus 1. And last problem. Find the sum to infinity of a series. One by 1 into 3 plus 1 by 1 into 2 into 3 into 5 plus 1 by 1 into 2 into 3 into 4 into 5 into 7 and so on. So, okay, but the denominator is not in the form of factorial. Okay, how to solve this problem? What is the first step? Any idea?
Sir, first term you have to multiply by 2, sir. Numerator and denominator.
Okay, Rahul, correct. Okay, very good. What about the second term?
Multiply by 4, sir.
Yes, multiply by 4. Here multiply by
6.
6. Very good, Rahul. Okay. So let us take s is equal to 1 by 1 into 3. 1 by 1 into 2 into 3 into 5. 1 by 1 into 2 into 3 into 4 into 5 into 7. Okay, so because here I want to write the denominator in the form of factorial, so but I don't have here 2. So if I have here 2 1 into 2 into 3, then you can write 3 factorial. So that is the reason I'm going to multiply and divide by 2. So 2 by 1 into 2 into 3, so I directly write 3 factorial. Similarly 4 by 5 factorial. Here 6 divided by 7 factorial. Now this is in the form of factorial, then you can find the nth term now. So nth term Tn equal to, the numerator is what? 2, 4, 6, so 2n. The denominator is 3, 5, 7, so 2n plus 1 factorial. Okay. Here, Bhavan, now I can add and subtract what? 1. Okay, but here it is a little bit easier. Okay, the numerator is also linear, the denominator is also linear. Okay, so here, if you see here, I want to write the numerator in terms of denominator, just add and subtract 1. (2n factorial). So now 2n plus 1 divided by 2n plus 1 factorial is what? 1 by 2n factorial. And then minus 1 by 2n plus 1 factorial. Okay. So now I think n is starting from where? If I substitute n equal to 1, I got the first term. So, okay, so n is starting from 1. So T1. T1 is what? 1 by 2 factorial minus 1 by 2 plus 1, 3 factorial. Okay, so T2. 2 into 2, 4. 1 by 4 factorial minus 4 plus 1, 5 factorial. T3. 6 factorial. 1 by 6 factorial minus 1 by 7 factorial. Okay, and then if you want to write one more term, T4. 1 by 8 factorial minus 1 by 9 factorial. So S is equal to T1 plus T2 plus T3 plus T4 plus so on. So add vertically. So 1 by 2 factorial plus 1 by 4 factorial, 1 by 6 factorial, and so on. Okay, and then I took, if I add vertically, took minus commonly, minus 1 by 3 factorial plus 1 by 5 factorial plus 1 by 7 factorial, and so on. So what is the first expression?
E plus
E
power minus 1 by 2 minus 1.
Yeah, first term 1 is missing, that's why I subtracted. Correct, Paritosh. Minus
E minus
E minus
E power minus 1
E power minus 1
by 2 minus 1.
Yes. Okay, correct. Now, okay, I think minus 1 plus 1 gets cancelled. So E by 2 plus E power minus 1 by 2. Okay, I'll write minus 1 minus E by 2 plus E power minus 1 by 2 plus 1. Okay, plus E by 2 minus E by 2 gets cancelled. Minus 1 plus 1 gets cancelled. So only these two terms. Okay, okay, this is what? This is 2 times, that is E power minus 1. Okay, e power minus 1 or 1 by e. 1 by e is the final answer. Okay. Okay, I'll stop here. Okay, we will solve some more problem tomorrow in the exponential series. For the second test, I think you are preparing for the second test. So concentrate, especially I already told that the diagonalization part is very important. Diagonalization by similarity transformation and orthogonal transformation. Okay, and then quadratic form, especially the assignment part you wrote that quadratic formula rotation of quadratic surface. Okay, I think that part is also important. And the population growth model we discussed. Okay, the application part. So I think in the first CA also you faced some other application problems. Similarly, this time also, so work out some application problem what we discussed in the classroom, and also your assignment problem also. Please go through it. Once you finish the matrices, and then you study theory of equations. Okay. So thank you, everyone.